Now let's talk a little bit about kinematics. Kinematics is a fancy word that simply means making calculations to convert between the quantities changes in position, changes in velocity, and acceleration. Kinematics allows you to exchange information between these three quantities. Let's start with calculating velocity based on changes in position and, of course, time. We already know how to do this. Velocity is equal to the change in position, or displacement, specifically, over the change in time. This is pretty easy. What about going backwards? What if we have velocity and time, and we want to know the distance traveled? This is also very easy. We just take our equation, v equals x divided by t, and rearrange it a little bit. We can multiply v by t, doing some basic algebra, and we get that x equals vt. This means that the change in displacement is equal to the velocity times the time that we've traveled at that velocity. Let's try this out. We've got a T-Rex, and his velocity is 10 meters per second for 6 seconds. How far does he travel? Let's see here. Our equation was x equals vt because displacement is equal to the velocity times the time. So x equals 10 meters per second times 6 seconds. Our units will cancel out nicely, which is handy. Then we're left with x equals 60 meters. This is our T-Rex's change in position. What if we're given a change in velocity with respect to time, and we want to know the acceleration? We already know how to do this, too. Acceleration is equal to the change in velocity divided by the change in time. Easy peasy. What if we want to do it the other way around? Let's say we've got an acceleration and the time at which we move at this acceleration, and we want to know the velocity, or the change in velocity, I should say. Again, we have to do some rearranging. We know that a is equal to the velocity divided by the time. So we'll move the t over here, doing some algebra, and we wind up with v equals at. This means that the velocity is equal to the acceleration times the change in time. This is the change in velocity. This means that if we start at a velocity of 0, we start at rest, this will be equal to the final velocity. But if we already have some initial velocity, v0, then this is only the change in velocity, which we have to add to that initial velocity. We'll learn more about that later. Let's try an example problem. This T-Rex is accelerating at 3 meters per second for 4 seconds. Let's calculate his velocity. V equals a times t. So his change in velocity, delta v, is equal to 3 meters per second squared times 4 seconds. Seconds cancel out, so we get his change in velocity is equal to 12 meters per second. Easy as pie.